Hi, good afternoon. We are Robo Mayhem. My name is Preeti Patel, and my teammates are Jisoo Shin and Emma Bishop. For our capstone project, we created a web version of a popular board game called Robo Rally. It's a multiplayer strategic game where players, aka robots, race to reach the multiple checkpoints while overcoming obstacles along the way, such as death lasers and gravity pits. So think of it kind of like capture the flag, except that you're a robot and you need to calculate out each one of your moves before you start making them, and you need to take into consideration the various obstacles you may run into along the way. In the board game, players have to manually, move their robot pieces around and imagine the obstacles. And with Robo Mayhem, our goal was to allow users to experience Robo Rally come to life. In our application, a user can access the game lobby, which shows all the games that a user can potentially join. So our games are stored in Firebase, and games in a particular waiting status are the ones that are displayed on the front end. If you just wanted to create your own game, you can do that as well. You pick a board, which vary in level of difficulties, and you choose your robot avatar. Other players can then subsequently join this game through the lobby, and then once the host determines that enough players have joined the game and they want to start the game, they hit go, and that takes all the players to their own game state. Emma's going to now go into details on how to play the game.
Thank you, Preeti. So, when the game is initiated, each player is randomly assigned a starting point and dealt 9 cards. Their task is then to choose the 5 cards that will best move them towards their next checkpoint. Once all players have done that and pressed ready, their moves will be played out on the game board. We wrote the game engine on the back end using Mongoose methods. It captures each player's current position and then calculates their next position based on the cards they chose. It will then calculate their following position based on the characteristics of the tiles they've landed on. Players on conveyor belts will be moved along the belt, and players on gears will be rotated. The complexities of moving players around the board make this particularly well suited to a web version. With the physical game board and pieces, it is really easy to lose track of where you are in this cycle of card move, board move, which is repeated once for each of the cards. With our version, the game engine takes care of that entirely. Jisoo will now go into more detail on some of the technologies we used.
Thanks, Emma. As we were planning out our application architecture, our primary concerns were to address how the evolving game data object should flow between the client and the server, and how to display the state of the game on the front end. Once all of the players within a certain room have registered their cards and pressed ready, a request is sent through our Angular factories, which is our front-end model layer, to our node process. Our node process initiates the game logic and calculates the next game state. This game state is then sent to Firebase, which we've used as a central repository for managing all of our connections and propagating data to all of our clients in real time. In addition, we also occasionally persisted our data to MongoDB. On the front end, Angular is listening for these changes in Firebase, and then the visualizations are rendered. For our graphics, we use a graphics library called Pixie.js to display the game board, to create robot sprites, and to move these sprites based on the data we receive from the backend. Our application architecture organizes our data flow so that players can solely focus on their game strategy. Emma, Preeti, and I had a lot of fun building out our game, and we hope you enjoy Robo Mayhem.